Hey everyone, in this video we're going to look at how we would draw a line of best fit, kind of eyeing it by hand, and how we would use that line of best fit to estimate a couple values. So the first thing we see here is we have some data that shows the weight of an alligator at various times during a feeding trial. Our independent variable is weeks going along this way, so weeks going this way. And then going vertically, we have the weight in pounds. So we'll call X, we'll call weeks our X, and our weight our Y value in this example. And so our mean X value and our mean Y value are the first things that we would have to start doing. And mean, we just add up our weeks and divide by how many we have. So we've got 1, 2, 3, 4, 5, 6, 7 of these. And we would add those up and divide the X value, 0 plus 9 plus 18 plus so on and so on, divided by 7. And you can check this out on your calculator and you get about 25.7. And then we would do the same thing with the Y values. 25.7, lost my pen. And so we'd add our Y values up, so 6 plus 8.6 and so on and so on. And we would get a mean value here of about 12.89 weeks, or pounds. And then we're going to plot this point on our graph because our line of best fit, and kind of think about it this way, it's the average line of our data, so it should make some sense that it would go through the average X and Y value. So this point here, let's call X bar, Y bar, would be the point. Let's just go to the nearest tenth, 25.7 comma 12.9. It's called the center of gravity for our data, X bar, Y bar. And so we are at about 25.7, maybe a little off here, almost exactly at 26, and then about 12.9, so almost 13. And I missed a little bit. Let's just nudge this over a little bit over, and a little bit up. That looks pretty good. So our line of best fit, we're just going to eyeball this. So it's got to go through our center of gravity. Now what we're looking for is a line that is a trend line that approximates the slope of our data. We're definitely going to have a positive slope. So this needs to be a little steeper. I'm just going to play around with it a little bit and get it to a line that we feel pretty good about. But I still have to go through that center of gravity. And so what we'd be looking for here is equal number of points above and below. And a nice alternating pattern would be nice if we could do it. Not always possible. I think that's maybe a little bit steep. This is just a little trial and error. For now, we'll look at how we find the line of best fit a little more analytically. That looks pretty good. So for the sake of this example, we'll say that that's a very good line of best fit. So it goes through the center of gravity. So we know the equation of this is going to be, we can do point slope form. Oops, let's try yellow there would be a little better. So let's put this in point slope form. Y minus, it's going to go through the Y mean, so Y minus 12.9 equals, and I'm going to leave a little space here for our slope, and then X minus the X values mean, so we'll go 12.9 to the nearest tenth on this guy. Oops. Not 12.9, 25.7. And so the slope that we need here is going to be off our graph. So it's, from our center of gravity, I see it goes through this point right there. Let's circle that guy in green. So it goes through this point, which is our second to last data point, 43, 17.12. And we need to figure out what this rise over run is over here. So there's our slope of our line. And we'll just calculate this over here. So our slope is going to be the change in y over the change in x. So this y value up here is 17.2 minus the other y value is, we're using our center of gravity, so 12.9. And then the difference in our x values, we're using over here 43 minus this guy right here is our center of gravity, so that's 25.7. I'll let you guys verify this if you want, but we get a slope of about 0.25 for this. A little bit less than that. It was rounded to 2 decimal places. And there's an equation for our line of best fit. So 0.25 our slope. So if we want that in slope-intercept form, that might be an interesting exercise. You guys could just verify that you get the same answer that I do. In slope-intercept form, we get y equals our slope's 0.25 x plus 6.48. All right, so, and this kind of makes sense. What these pieces mean, our slope is if I go over 1, I'm going to go up 0.25. So our slope is our increase in the y value, which is weight, every time I go over 1x, which is a week. So this is the change in pounds per week. And then the y-intercept, a lot of times it doesn't have a whole lot of meaning to the problem, but in this case, after 0 weeks, we would expect our alligator to be 6.48 pounds. And that's pretty close to what the data shows. This is a line of best fit, so it's not perfect. But yeah, so that's how you go about finding the equation. Question 3 and 4 down here ask you to predict the weight after 10 weeks. And they may seem kind of repetitive, but there's something interesting about each of these. So, after 10 weeks, we'd get x equal to 10, so 0.25 times 10 plus 6.48. And we get about 8.98 pounds. LBs. And if we look over at our graph, that kind of makes sense here. 10 weeks here. Yep, 10 weeks over to the y-axis. Looks like it's about 9 pounds approximately. And we can do the same thing for this, 54 weeks. So after 54 weeks, plug in x equals 54. And we get plus 6.48. We get about 19.98 pounds. And again, we look over on our graph. I'm going to do this guy in red. So 54. Actually, I'm not doing a great job drawing lines today. So 54. Draw this guy up. And then over here, almost 20. All right. So these two last questions point out a couple terms that we need to be aware of. When we're looking within our data, so from 0 to 49, when we're looking on our line of best fit and estimating or approximating a value in between, we call this interpolation. And you might be able to guess when we go outside of our data set. So we're coming out here, and I'll switch over to this guy. So if we're going this way, or we're using it to predict the future beyond our data set, we call this extrapolation. I guess I'm going to have to extrapolation. And as you might guess, interpolation, always more reliable, usually pretty good confidence. You can say that is a good estimate. Extrapolation, you're either digging way beyond in the past before your data, or going out into the future past your data. And those extrapolations are a lot less reliable than an interpolation. The farther you go out beyond your data set, the less reliable your estimate is.